Hi, in today's lesson we're going to learn how to find the oxidation number an element would like to have using only the periodic table. In earlier lessons we've learned how to do that using an electron layer diagram and a bunch of pennies. But chemists don't exactly carry around a bunch of pennies. So what we're going to do is we're going to go through some examples here to show you how this works. Let's start with sulfur. So here's the periodic table. Sulfur is number 16. To find the charge an element would like to have, you count from the nearest noble gas to the element itself. So here are all the noble gases in this right-hand column: helium, neon, argon, krypton, xenon, radon, and the last one. So, in the case of sulfur, sulfur is number 16, which falls between 10 and 18. Well, 16 is closer to 18 than 10. So here's our nearest noble gas, argon. We count from argon down to the element in question, sulfur. Since we're counting down, that means it will have a negative charge. So here's a -1, -2. That means our sulfur would like to have a charge of -2. Next up is magnesium. Here's magnesium. Well, magnesium is number 12, which falls between 10 and 18, and of those two is closer to 10. So here's our nearest noble gas. We count from the noble gas to the element. You notice this time we're going up, which means the charge will be positive. So here's +1, +2. So magnesium would like to have a charge of +2. Our next example is helium. Well, helium is a noble gas itself. Noble gases will not give or take electrons because they already start with the complete outer electron layer. So it will never get a charge at all, and its oxidation number will be just a 0. Our next example is aluminum. Aluminum is here, number 13, and 13 falls between 10 and 18. Now be careful here, 13 is closest to 10. Sometimes people just follow their eyes along, but that's not what I mean by closest to. I mean 13 is closer to 10 than 18. So here's our nearest noble gas. We count from the noble gas to the element. So here's +1, +2, +3. So aluminum would be a +3. Next up is silicon. Silicon is number 14, and what makes it tricky is that it's a halfway element. 14 is exactly halfway between 10 and 18. So for halfway elements, you have to list both possibilities. So counting from neon, this is +1, +2, +3, +4. From argon, this is -1, -2, -3, -4. So that means for silicon, you have to put +4 or -4. You have to list both. If you put only one of those, you would lose the points. Last but not least, I want to take a look at hydrogen. Hydrogen is a unique element because it has only one electron. Now, the nearest noble gas is helium, number 2. But it turns out that hydrogen can get a complete outer electron layer by either taking in an electron to have the same as helium, or by giving its one electron away and ending up with 0. Even though there's not an element 0, 0 electrons counts as a complete outer electron layer. So that means hydrogen is either a +1 or a -1. And again, you have to list both. So we have to put +1 or -1. Hydrogen is a halfway element, and it's the only element we study in this class that can be either a +1 or -1. So key takeaway, to find the oxidation numbers, we use the periodic table. You count from the nearest noble gas to the element.